HIMT, Hindustan Institute of Maritime Training.
Good morning, boys. My name is Kannan, and today we are going to discuss a subject or a topic with the arrangement of slop tanks in a tanker. Okay. So, for those who are tanker boys, they understand this term very well. They've probably been inside slop tanks and things like that. And for those who have not been on tankers, try and understand that there is a tanker which has got a few sets of tanks designated to carry liquid cargo from one point to another, and after the voyage is over, it is imperative that the tanks are washed and kept ready for loading the next cargo. That's the general concept. And how we go about washing is what this slop tank arrangement is there for. In earlier days, we used to take seawater, wash the tanks and dump everything over the side. But now we have strict protocol, and MAPOL does not allow you to do that, and penalties are very, very high if there is any oil discharged into the sea without proper equipment, whether it is from the engine room bilges or the tank washings from the cargo tanks. Okay. So, to put it in a nutshell, without going into the tank arrangement, etc., we have understood that there are a few set of tanks meant for carrying liquid cargo. We wash those tanks and we collect in designated slop tanks. Otherwise, you will require tons and tons and tons of water, and you don't have so much place to collect it, right? So, typically the arrangement is like this. We have slop tanks which are almost at the end of this tank rows. You got 1, 2, 3, 4, 5, 6 rows of tanks, maybe port, center, starboard, or only port and starboard, whichever it is. Towards the end, you have a slop tank. If you're looking at the slop tanks from aft like this, that's what I've drawn on the board. This is a port slop tank and this is a starboard slop tank. Right? Whatever I have drawn here, it can actually be a mirror image on some ships. Right? A dirty slop is on this side, a clean slop is on this side. On some ships, the arrangement could be a mirror image. It hardly matters. We only try and understand the principle behind it. Okay. To begin with, we fill up a certain amount of water in, let's say, the starboard slop tank. Okay. Naturally, it has got a pipeline or a set of arrangement pipelines, pumps, etc., from where it goes suction to the pump, right? If you're using a pump, the pump needs a suction line. So that's the suction line. It goes to the pump. That's the tank cleaning pump. The tank cleaning pump puts it across into the tank cleaning line or the cow line on crude oil tankers. And then you have separate lines for fixed machines. Yeah, mostly all the ships today, they all have fixed machines. But in olden days, you also had Butterworth pockets which you open up and lower a hose and wash it, 30 minutes each level, say 10 feet, 10 feet, 10 feet, or whatever, depending on the size of the ship. But nowadays, you do have portable equipment for an emergency. That is stored in your 4-peak store or wherever. Mostly, I don't think you have ever used it for washing, because your fixed guns are extremely good. Media cooled and media lubricated, absolutely no maintenance. Unless, of course, the tank cleaning line, the pipeline has got debris. Like flakes of paint come out over a period of time, it goes and jams the machine, and then you have problem. But then these are limited, and these are isolated incidents where you have, when you're washing at a very, very high temperature, 80 degrees centigrade through the pipelines, maybe the paint coating is not supposed to take that kind of a heat. So it starts flaking out, and goes and jams your filters on the tank cleaning machines. But that's a separate subject. Anyway, so the tank washing machines are hammering all the old cargo, everything is down, and you strip it and put it back into the same guy. Okay. This happens for some time. Some people do not take water initially. On some ships or some companies, they don't take water initially. They take seawater, start washing, and keep filling it up. keep filling it up till a particular level. So what will happen? Once the collection in that tank comes up to a certain level, there is oil on top, clean water below, correct? You can have an interface taken. You use your UTI tube, alleged temperature and interface measuring equipment. There is a particular equipment on tankers which can give you alleged, it can give you an interface also, and also read out the temperature of the cargo or whatever is the liquid inside here. Okay, you use that and you can make out that oil is probably up to this level, good clean oil, and then there is this interface area, and here in this much area is good clean water. Okay, at this point you stop taking seawater inside your system. Now you start using this clean water and you start washing your remaining tanks. Okay, at a certain height there is an arrangement, there is a pipeline which connects this slop tank to this slop tank. Most people try and say it's an equalizing line. It is not an equalizing line. It is a decanting line. Okay? And for the purposes of segregation, you will have two valve segregation here. Just in case your port side cargo is different from your starboard side cargo, you are complying with the two valve segregation for different cargos. Okay? So you obviously open those two valves and let the oil part decant here. Keep taking good clean water from here, wash, dump the whole thing into this, the oil goes and decants. So you have decanted oil being collected elsewhere. This is a wonderful method. Most tankers today, you can finish your tank washing operations in less than 12 hours. Gone are the days when we were cadets, and in the early 80s, we had a lot of tanks and it would take us probably 3 days to completely finish tank washing and then do whatever else we set out to do. Okay, but today tank washing 6 to 8 hours at best if you're prepared. Hot water, perhaps a little more time, but that's about it. What kind of wash, hot water wash, cold water wash, things like that, depends on which cargo you have carried and what is the next cargo you're going to carry. Okay, so you have series of matrices are there by Shell or by Mobil, and all these guys, they have their own matrix. So does Indian Oil Corporation of India. Okay, so they tell you A type cleaning, B type cleaning, from this cargo to that cargo. Okay, then we collect at the end of the tank washing sequence. You have finished all your tanks except the 2 slop tanks, correct? At the end of it, now you have something here and something here. This is almost full, right? You allow it to stand for 24 hours. That's a requirement. You let it stand for 24 hours and then you will have this interface level will reduce. You will have good clean water here on the bottom. Then you run it through the ODME and discharge it overboard. Okay? The ODME requirement, as the MAPOL says, is the ship must be en route. Okay? It should not be stopped and drifting in one place. It should be en route. The speed must be a minimum of 6 or 7 knots.
7 knots.
Perhaps.
Not being special area.
Not to be in a special area, yes. And you must send it out through a equipment, special equipment, where 15 ppm should not be more than 15 ppm when you are pumping it out. Okay, and there is also a requirement for the nearest land. You should be at least so many miles away. I don't know, the rules have probably changed now. I have no clue. Okay. We have decanted. Now, what do? We have to get these 2 tanks also ready for loading the next cargo. These are cargo tanks. Nowadays, charterers do not like to hear the word called slop tank. They don't want to hear this name called slop tank. Why? Because that tank is all the time dirty, I don't want to load cargo there. So what happens then is, that much is dead freighted. The owner is at a loss. So now they have renamed everything. There is nothing called a slop tank. They are also cargo tanks. 1 port starboard, 2 port starboard, 3 port starboard, 6 port starboard, and 7 port starboard is actually designed like this, where you can use this as a slop tank arrangement. As far as the charterer is concerned, or the guy who is receiving a cargo is concerned, this is as much a cargo tank as the others, right? So that small bit of a thing is out. You still have to get this ready. Now what do? We transfer the contents after decanting. You got a little bit left, okay? You transfer all the content here, okay? You wash this tank and collect it here. So that tank was also washed, clean. Now what do we do with this? Again wait. Because you have freshly unsettled it by putting the tank washings of this into this, correct? You allow that to settle. Decant again. Now you got a small bit of a residue, which is normally not too much, it's just a little bit. In some tankers, they have a provision called residual oil tank. Residual oil tank, which typically is nestled in this kind of a space. Now see, again, this is a two-dimensional image I am showing, but you try and understand that the tank is of that length. The ROT could be somewhere here and not here, okay? It's just a residual oil tank. Very smart thinking on the part of the owner, because not always you can find a facility which can receive your slops. Not always. Sometimes you're stuck with that for a long time, and it might be economically not viable for him to divert the vessel and go to some place which has got a slop reception facility. Some terminals have got, yes, but not all. Again, these are all areas of improvement to cut down on time, to avoid wastage of money. Sometimes you are diverted to Fujairah and de-slop in Fujairah, and at the same time do bunkering, and then go over the load ports which are typically there in that Arabian Peninsula, yeah. At that time, if you don't have an ROT, when you are de-slopping into a barge, you discharge this content, also wash this and pump it into it. That way this tank also is clean, correct? But when you have an arrangement of a residual oil tank, you transfer all this quantity into the ROT, wash this and dump it into the ROT. By design, it can be done. The size of the ROT is such that by design, you should be able to achieve this. Wash the two slops and collect the residues inside the slop tank, residual oil tank. After washing is the next process, right? We are washing this in an inerted atmosphere. I'm not touching those topics because we have discussed that before, right? We are washing this under inerted conditions. After all this is done, then we are gas freeing it. Before gas freeing, we purge it to make sure that it is less than 1% of hydrocarbon by volume. Okay? Are you from tankers? No. Okay. We need to have a separate class trying to discuss about what happens from one loading to another loading, or the entire cycle. That will probably put things in a better perspective than what you're trying to understand right now. Okay, so slop tank, this is the arrangement. You will have, I've only discussed the principles of decanting from one point to another, but arrangement wise, yes, in the slop tank you'll always have heating coils. Okay? Normally all slop tanks will have heating coils. Whether they are made of stainless steel or Yokai Pro or whatever else is besides the point. Depends on how much the owner has invested. Okay? There will be also sounding point. You constantly need to take sounding, isn't it? So sounding point is provided in this as much as it is provided in a cargo tank as well. Point to sound, instead of calling it a sounding pipe or a sounding point, you will have several points from where you can take soundings. It will also have a tank dome. It will also have a IG inlet, a pipe from where you can put inert gas in or fresh air in for that matter. Okay, so all these, just like a regular tank, these tanks also will have all those same things. Okay, the only additional component is this decanting line. On some ships, on very few ships I have seen, they also have an equalizing line. They also have an equalizing line. For what purpose that is given is besides the point, but they also have. Construction wise, you might typically find that this is there in all the slop tank arrangements, port and starboard. Sometimes you also have this, an equalizing line between two tanks, also with individual valves. So again, the two valve segregation, that criteria is met. Okay? Any doubts in the slop tank arrangements? No? All clear?
Yeah.
Tanker boys, non-tanker boys? Yeah, all clear?
Yes, sir.
It's actually a very simple thing to understand. This is only the concept. When you guys go back on ships, right? You're going to be what? Probably third officers or fourth officers. You will probably be dragged down to assist the chief officer when it comes to tank cleaning. Yeah? One man, extended hours. So generally, junior officers are called down for assisting the chief mate. So you will well be probably using such a system. So this is just a familiarization for you right now. Eventually, when you're actually on board the ship, you will find tank cleaning a lot more easier because you've understood this concept, isn't it? Sometimes when you're doing hot water, you do the same process, and once it comes up to the decanting thing, then you start the heating coils and start heating. Till such time, you'll be taking seawater, running it through the Butterworth heater and pumping it through the tank cleaning line. Till the time, the slop tank has got a reasonable amount of water in that. And you start heating once the heating coils are submerged in water and not oil. Once you've got a couple of feet, you start the heating coil.
It takes time to settle down.
What?
Water and oil.
It'll take care. But generally they are immiscible, right? It will not take time to settle down. What takes time is for the interface to reduce its height. Oil, pure oil is still there. Small particles of it are still meandering through the principal medium of water. That's about it. And if you're not agitating it anymore, it will slowly give you actually a very, very fine line. At the end of the day, oil is oil, water is water. Given sufficient time, yes, you will find a simple line, straight line. Exactly, oil is stopped there and water is below that. You know that pretty much exactly. But what you have to be careful about is while you are decanting it from the suction pipe, it forms a wall. You understand the word? Wall, eddy, right? If you are drawing this at a very high speed, what will happen is that surface, whichever is the surface, in any tank for that matter, forget about the slop tank, in any tank, if that's the level of the liquid and you're trying to take it out, you're pumping at a very high speed, okay? After the first few minutes, what happens is, on the surface, it is like a whirlpool, A vortex is formed and what is on the surface gets sucked in, which is not in your interest, isn't it? So decanting then obviously becomes a process where perform slowly. Yeah? The owner thinks that you are familiar with such operational techniques. The owner thinks, and you fool around and fatafat karne ka yaar time ho gaya hai. What you are doing is you're actually putting all this into an ODME where ODME will automatically shut off. Right? It will stop discharging overboard and start putting things back into your slop tank, and thereby again agitation. The minute there is an agitation, you're getting more delayed, right? So remember, decanting you must do at a speed where it is not, a vortex is not created from the top surface and bringing oil into the system. Okay? So it's a slow process. Don't hurry it up. Okay? Not many people think about this because they are in a pressure. Whenever you are doing tank cleaning, you are under pressure because of time. Huh? You have to do tank washing, you have to do purging, you have to do gas filling, then you have to, in some cases, you send a man down there to wipe out all the slime and grime and all that, and then you have to re-inert. It's a process which takes time, isn't it? So everything is allocated. This much time I need for this much time I need for this. So the chief officer has got a plan and he's got a schedule. By this time I need to do this. And the captain also is continuously giving feedback to the other people who are concerned, like, where exactly are you? Yeah, I'm in this process. Okay. So when you are under a constricted time frame, you are likely to make mistakes. You're likely to make mistakes. Please don't make this mistake. It will stall you for a few hours easily. Okay? Understood? All clear? Any doubts? Any doubts, beta? None at all? Okay. That completes our slop tank arrangement. And now we will discuss something called precautions to take. This is actually a tanker lecture going on, right? I mean, for boys who are thinking like what is going to be the next topic. Today all topics are going to be concerning tankers and tankers only. Okay. We will discuss the precautions to be taken. Why? 1, 2, 3, 4. You need to take precautions every time, yeah? While loading, what precautions you take? While discharging, what precautions you take? While tank cleaning, what precautions you take? While bunkering, what precautions you take? Okay? Okay guys, yeah, welcome once again. And we have finished the slop tank arrangement. Now we are going to look at a few precautions what we take on tankers. Like precautions while loading, precautions while discharging, precautions while tank cleaning, and precautions while bunkering. Okay? So these are the various precautions what we need to take. And we'll start off with the bunkering checklist. Okay? Now, as you guys are aware, please, as you guys are aware, in addition to your CLC 92, does it ring a bell? What is CLC 92? Civil Liability Certificate. That covers, by and large, pollution, right? There's something called bunker CLC. Now it is mandatory for you to have bunker, right? So bunkering, and during the process of bunkering, overflows happening has all been there for a long time. So this is an additional certificate which you need to possess, as well as the bunker guy. He also needs to possess that. Okay. So forget about all these legislations. We come to what is bunkering and how we mitigate, or how well we prepare ourselves to mitigate in case of a spill, right? But first, bunkering. What is the bunkering thing? What happens when bunkering? And what are the checklists to follow during bunkering? Typically, most of the things are very, very similar to precautions while taking taken prior loading or prior discharging. They're very, very similar. Bunkering also is pretty similar, but see the salient points. Bunkering oil spill. Quick reaction is essential in containing the spill on deck. The source of oil spill must be stopped. The chief officer will direct containment and oil cleanup. The risk of fire should be appraised and precautions taken to ensure oil soak mopping equipment. In case there is a spill on board your ships, you must have had spills, yeah? Whether it's a cargo vessel or a bunker vessel or a tanker vessel, you must have had, right?
Yes, sir.
How did you clean it up? What kinds of sawdust and absorption pad and OSD? No. No, I'm talking about the material which you have used to mop it up. Yeah, and oily rags and things like that, yeah. Okay, remember one thing, every time, whatever material you have used which has been soaked in oil and kept aside is prone to yeah, it is prone to what? Auto ignition. Yes? It's an exothermic reaction which happens when oil, sawdust, rags, all these are soaked in oil. Okay? I mean, not oil. Rags and sawdust and other materials soaked in oil and kept aside for some time. It's an exothermic reaction. It will start a fire. Okay? So, disposal methods have to be quick. Right. The chief engineer will authorize hot work, etc., etc. That's it. Okay, so bunkering, in earlier days we used to take the bunkers and put it in our tanks and start consuming it, whether it's diesel oil or heavy oil, right? There was no procedure in place to see whether the bunker which you have received is actually compatible with the equipment what you are using that bunker for. Okay? There was no procedure in place, but today there is. Today what we do is we take the bunkers, we put it in a separate tank, preferably an empty tank. We take samples during the bunkering, we send the samples for analysis, and unless we get an analysis report, we do not use it on our equipment like generators or main engines or whatever it is. Okay, this is pretty much followed by all companies to safeguard the equipment like a whatever engine room machinery they are using it for. Okay, so this is one of the things today. You take bunkers, store it in a separate empty tank preferably, and send it for analysis after bunkering. Wait for the analysis report to come before you put it to use. Okay, so bunkering process itself, procedure itself is something. There has to be a bunkering plan. Just like you have a loading and a discharging plan, the chief engineer makes out a bunkering plan along with designating a particular person for a particular task. Okay, bunkering plan will have this person does this, this person does this, this person does this, and who is the overall in charge. And he also gets assistance from the chief officer towards spillage precautions on deck. Correct? In case something happens at the manifold. So it's all going to be spillage on deck only. So the deck department also participates in this bunkering procedure, okay, or bunkering act. The guidelines noted here under refer to the procedure which involves transfer of fuel oil, diesel oil or lubricating oil, whatever. Personnel and duties. Overall in charge is the chief engineer, and he undertakes the overall charge of procedure and is responsible for carrying out the task in a proper manner. Determination. First, what the chief engineer will do before you send out your request for bunker, the chief engineer and the captain will sit and calculate how much bunkers we need to perform the voyage, isn't it? You're going for a loading at a certain port, and you know you're going to go so many days away to discharge port, and whether there is bunkering capability at the discharge port or not, I don't know, and which is the next nearest bunkering port. So all those distances and the consumptions are taken into account before a bunker order is placed. Okay? Isn't it? Yes. How much bunkers you need to perform this voyage? Simple. That's the reason you're going to take bunkers. So you do all those calculations and send your request to your office, and the office staff coordinates, gets a bunker supplier at your port where you are arriving, whether it's Fujairah or it is Singapore or it is wherever. Okay, so determination of the amount of oil that the ship can take. The ship can take is one thing. Sometimes the charter says top up your tanks, you know, fill up everything. So then you calculate, okay, how much I have now and how much I will have by the time I reach the bunkering port. So minus so much, and this is loading all my tanks. Mostly they say how much do you need to perform the next voyage. Okay, either which way, determination of the amount of oil is required, and specifications, what exactly are you using, what your company SMS tells you, what kind of an oil you're supposed to use. You order for that oil, okay, or that particular parameter has to be taken into consideration, the exact specs. Preparation of the bunkering plan is establishment of the bunkering organization and allocation of related duties to the other staff. Verification of preparations and safety, right? Normally on tankers, it is one person executes what has been told, line up, which means if you're going to take bunkers into a particular tank, one guy does the line up, one guy verifies the line up. Okay, it's always important to verify. What valves need to be open must be kept open, but you must also verify that what are not required are actually closed. Open valves are open is verified, and what is not required, closed valves must be in closed positions. So one person does the lineup, one person verifies. Sometimes the chief engineer might verify it himself for the sake of good order. Okay. Then you liaise with the bunker suppliers. Any oil which comes on board, whether it's cargo or it's bunker, you always take samples. You always take samples in the presence of the other party. Like in case of bunkering, the bunker barge representative will come on board, and when you are taking samples, he countersigns that label, right? That's evidence that this was a joint operation. So tomorrow when claims arise, you cannot say, or the insurance doesn't say, oh, this is a unilateral sampling which holds no value, it holds no water in my, I'm not going to pay your insurance. So it is always necessary to have samples drawn in the presence of another party who is not a ship staff. Similarly, when you are loading a cargo also, during cargo loading you take that in the presence of the cargo surveyors and the loading master. Okay? Any doubts? No. Okay. So sampling. So as soon as it comes, you take the samples and you verify initially whether you're loading cargo or you're loading bunkers. Initially the transfer rate has to be slow. It must be slow, so you verify it is actually reaching the designated tank or not. Once you have verified, then you open the other tanks or whatever else and increase the rate of bunkering or rate of loading. Okay. Verification of preparations, liaison with bunker suppliers, supervision of testing of samples at the start and during the bunkering operations. Now, MSDS. Can anybody tell me what is MSDS? Very good. Material Safety Data Sheet. Yeah. It tells you in case what happens if you have ingested it. Nobody's going to drink it, but in case ingested, what happens in case it falls in your body? Okay. What are the compositions there? What's the benzene content? What's the H2S content? Typically, these are the things we are interested in a bunker sample. So some company SMS tells you, before bunkering, measure H2S of your bunker tank in which you are intending to take your bunkers. During bunkering, check H2S. At the end of the day, after everything is finished, take H2S. They want these H2S readings. Okay, it's compulsory. They have a checklist. Well, all companies have got all kinds of checklists. This is one such checklist available in some companies. Right? During the voyage, you are supposed to monitor the H2S presence in your bunker tanks. Okay. MSDS is obtained and you get all those specs related to that bunker sample or that bunker which you are taking. Assistant to the chief engineer, who is the bunker officer, he'll nominate somebody. The chief engineer nominates that you are assistant, my assistant, depending on the time, daytime, night time. Sometimes one engineer has worked, overworked, he is resting, so the other person. So it's either typically the third or the fourth engineer. Supervision of all bunker operations, including the preparation, bunkering work, post-bunkering, restoration work, detailed instructions to workers. That assistant is actually executing all these jobs. Connection of a bunker hose, verify that the opposite end or the other end is blanked and fully bolted. Okay, these are the industry norms today. If you are connecting a hose to your manifold, please make sure that the opposite manifold is fully bolted, yes, blanked and fully bolted, and of course it needs to be, the valve also is closed, and then the manifold or the spool piece or whichever is there, under it there is a drain. Make sure the drain also is closed. As I said, all valves which are not required to be in operation must be kept closed, and only those which needs to be open needs to be open. Okay. Supervision, right. Liaison with the bunker barges, you will always have a constant walkie-talkie communication with them, and you engage in some kind of a code. Stop. What should I say? Should I press the bell, or should I whistle, 3 whistles, 4 whistles, whatever. Or typically, if you have walkie-talkies, you call the other guy and say, please stop. Okay, an emergency has arisen, so please stop. Okay, you must have communication with the other guy. The channel, walkie-talkies have got several channels, right? Somebody fooling around with that can actually go off and you're not in communication. So write it down. Channel for communication is so and so on walkie-talkie, this particular model. Okay, all that is there in the checklist with the next man you're talking to. Okay, taking soundings. So as you're loading, you must constantly keep checking what's the level, right? So you have to measure, just like in a cargo operation during loading cargo on a tanker, you constantly monitor, right? Similarly, you do that here also, you constantly monitor. Take soundings. Also, bunker barge initial and final soundings, ullage of all tanks and acknowledgement taken of this from the barge master. Although this doesn't really have any bearing on us. What we load, what bunkers we receive is of more use to us rather than checking somebody else's tanks. But this is one procedure which is suggested. Some people actually do it, some people do not do it, right? End of the day, we have a surveyor who checks our bunker tanks prior bunkering and post bunkering, and those figures are the ones which have actually any relevance. Okay, so checking on oil, specific gravity and calculation of amount of oil received, yes, obviously. Checks on ship's heel and trim. This is where the chief officer assists during bunkering operation, because the chief engineer might have a set of tanks on port side and less number of tanks on the starboard side. So you end up getting some list. So the chief officer is typically entrusted with the responsibility, please maintain 0 list. Trim is unavoidable. If you are on a ballast passage, you will have the trim regardless of what. Probably in a laden passage, if you are bunkering, which you normally don't, you'll pretty much be on an even keel, or you can achieve even keel status. Okay, but trim is something which can be used to calculate cargoes, all your particulars of tanks, or you have trim correction tables. But list, try and monitor and a 0 list. Okay, try and maintain 0 list. Watch keepers, of course, the deck needs to be continuously monitored for leaks. Although bunkering line pretty much is only a single line for heavy oil and a single line for diesel oil. It comes from the manifolds, comes into the engine room. Sometimes you also have near the break of accommodation, you might have another set of manifolds, you know, for catering to smaller bunker vessels to come alongside. The midship bunkering lines cater to a big vessel which can be brought alongside and tied. So the midship bunker points are used. If it's a smaller barge or something, it can come aft and you have another set of bunker lines. Regardless of that, you monitor that there is no spillage, there is no leak. Okay. Watch keeping on oil. Verification, reporting of the completion. After the whole thing is done, you make sure that the pipeline is also drained. It's important. After bunkering operation, after cargo loading operation, you must make sure that the top lines are well drained. Okay, because you have clingage inside the pipeline, and then during a voyage the sun beats down on you on the deck, you have expansion. Liquid is finitely compressible, vapors are not. So as the pressure builds up, it probably bursts some weak point, you know, some weak point. Maybe a valve is a weak point, it can blow up a valve. So it's very important that after all loading and bunkering operations, you ensure that the line is well drained, or line it up in such a manner that it is open to only one tank. Many chief engineers, after bunkering is over, what they do is they close all the bunker manifolds and every other valve, but maintain that line up all the way up to one particular tank. So the expansion is adjusted, and if you are on a ballast passage and there is a trim, it will slowly, it's more viscous, right? It's not like petroleum. Heavy fuel oil is more viscous. So you will have some clingage and residues on the pipeline which takes time to flow back. Okay. Some people also monitor it by putting a pressure gauge. Keep the manifold valve open, keep every other valve shut, and monitor the pressure gauge at the manifold. Every day the chief engineer takes a walk, or the second engineer takes a walk, he sees, okay, oh, okay, fine, there's no pressure. So monitoring of pressure is another way, but monitoring and make sure that there is not any expansion of gases inside the pipelines on the side. Okay. Now, most important, end of the day, make an entry in the checklist that you have finished all this. Assistant to bunkering officer, obviously he will require some assistance. So a couple of engine room ratings, oilers or wipers or whoever else there is, yeah, to take checking the air vent for flow of air, arrangement of empty trays for receiving leaked oil, in case there is a leakage, preparation of equipment and materials. All this is done before basically, like you come, the bunker barge comes alongside or the terminal connects a bunker hose to you, you are prepared, you got a couple of fitters with the manifold to do all the connections, yeah. Maintain watch on oil spills and leaks, etc. Spareman as designated by the chief engineer. As per the situation, if you require extra hands, yes. There are not so much people in the engine room, right? So if extra manpower is required, yes, the deck crew can also be called in to assist. As the situation demands, assisting in preparation for bunkering operation, post-bunkering restoration, etc. Spareman as designated by the chief engineer. Deck department personnel should engage in the following items of work to assist in the bunkering. Mooring and unmooring operation of the supply barge, in case you are taking it from the supply barge. In case of a terminal, then of course you make sure that the moorings are in order, the gangway is in order, and all your scuppers are plugged, your oil spill response equipment is readily available at hand. These even container guys or bulk carrier guys also do the same thing, right? Yeah, you prepare for bunkering and you have all these things standby, ready to use if required. The necessary spanners for that particular bolt, whatever size is there, the necessary gaskets here. Okay. All the scuppers, yeah, scuppers are plugged, OPA equipment or oil spill equipment, everything is ready, yeah. Things which are pretty much in your mind. Arrangements for flying, posting signal flags or lights, yeah. In some cases, in some countries, they want you to display a particular signal flag or a particular set of lights to indicate that you are engaged in bunkering operation. Okay, so arrangements for flying, posting signal flags, watchkeeping of possible spillage, accidents, etc. Keep a watch oversight also during the process of loading or discharging or bunkering. Always watch the surface of the water. Yeah. Information. Following items will be displayed prominently near the transfer facility and must be in large bold letters. The ship's bunkering pipeline diagram should be. This is a requirement now. Ship's bunkering pipeline diagram to be displayed is not done before each bunkering operation. It's as like a mustard list. It's fixed, permanently fixed. That piping is not going to change until you go to the next dry dock or refit and something is altered, right? So that bunkering piping diagram is fixed pretty much on some alleyway. You're near your cargo control room or perhaps definitely one in the engine room as well. Okay? So this is not something which you do each time. It's done once and dusted. Oil tank layout with associated vent piping again. Tank capacity is full. This also is there. Like your port heavy oil tank or whatever, starboard heavy oil tank, that's the total volume. That's the 98%, that's the 95%, that's the 93%, etc. Normally bunkering operations you must have seen. On cargo operations, the chief officer loads and tops up all the tanks to 98%, correct? That's what the tankers do, yeah?
Yes, sir.
In bunkering operation, how much does the chief engineer go up to? Have you noticed? 98. Normally 95%. Normally. These are all, where do you find this information? In your company SMS manuals. Each company gives a directive. It tells, please do this, It doesn't give you a choice. Yeah. Do not go beyond 95%. This is the recommendation by the SMS. If the chief engineer feels a little, oh yeah, no, he can also go less than that. 94%, 93%. It depends entirely on his level of confidence. And the last bunkering tank, if you're loading bunkers into 5 sets of tanks, let's say, normally the company also tells you the last bunkering tank load only up to 90%. Some companies, some chief engineers also do that. The very last bunkering tank is typically a very, very small tank. They don't go into the biggest tank for final, isn't it? when you have big tanks, medium tanks and small tanks, what is the general idea? Fill up the big ones, then come to the medium ones, then come to the smaller ones. So the last tank is almost always a small tank. That's the reason the chief engineer stops at 90%. It makes very, very good sense. Loading rate is so high and the tank is so small, before you could say anything, it's gone up. So, makes good sense. It must have the information in the MSDS, must have the product description, its generic name, like fuel oil. Typically, what's the viscosity, what's the specific gravity, flash point, color, order. Diesel oil, similar. The lubricating oil, similar. Product handling precaution should be given in the MSDS. Products are non-toxic, in very rare cases can cause allergic reaction, things like that. Depends on the amount of benzene, H2S, and these are the ones which actually are killers, isn't it? Okay, the bunker lines, just as cargo pipelines, they have to be pressure tested. Every 5 years, twice in 5 years in dry dock, it should be tested to 1.5 times the design pressure. Where do you get the design pressure of this bunker pipeline or cargo pipeline for that matter? So you want to call the manufacturer and ask him, hey, Charlie, kitna hai? Your drawings, your hull and machinery drawings, typically they give you 3 sets. One set is there with the chief engineer, one set is there with the master, and one set is there in the ship's office or some common area where people can access, Anything to do with your equipment, that tells you what is the design pressure. Okay, and then you work forward as you see, okay, my ship is 15 years old. Although this is the design pressure, I know it's not probably going to take it, yeah. So whatever pressure you are testing it to, please stencil it on the pipeline concerned and do not exceed that kind of a pressure what you have used for testing. Okay. Any of you did any pressure testing? What? Cargo pipelines? Cargo pipelines are pressure test. Bunker pipelines, anybody has seen anybody testing bunker pipelines? You have? Okay. How did you pressure test these pipelines? Whether it's by air? By air, by water. And by what? Huh? This is a common question for all, whether you're a bulk carrier man or containers or whatever. How do you pressure test? Huh? Bunker line or cargo line, whichever. You've tested cargo lines?
Maximum pressure.
You use cargo from the tanks.
Then only increase the maximum pressure that the pipe can
Cargo line you test with cargo?
Yes.
Your chief also did that?
Yes.
LPGs? LPG, okay, yes. LPG and LNG tankers, on LPG and LNG tankers, those tanks do not see seawater. You never wash them with seawater. So that's a very specific trade. On oil tankers, conventional crude oil tankers, chemical tankers, you never test your pipelines with cargo. You never ever do that. You pressure test your pipelines while you're doing tank cleaning. You pressure test your pipelines while you do tank cleaning. Okay. That's the time you pressure test, and pressure testing methods are improperly adapted by most seafarers. What you stencil is static pressure tested to XYZ kilos. Yes, that's what you write. Huh? Yeah, correct. Bars or whatever it is. What do you understand by static pressure test? What do you understand by dynamic pressure test? Dynamic is anything moving. Static is anything which is stopped. What you end up normally doing, what most people do, is they do a dynamic pressure test. It's wrong. Well, you can of course. But that is not the idea. You're supposed to do a static pressure test. Which means you pressurize the pipeline up to a particular pressure. XYZ kilograms or XYZ bars, and then you hold that line tight and watch for drop in pressure. A static pressure test tells you if there is a leakage. A dynamic pressure test does not. How will you say that this system is tight? 15 kilos, I have tested it to 15 bars. How do you say that? Only when that particular set of pipeline, piping, valves, everything has been set at 15 pressure, 15 bars, and then you watch the gauge. You let it stand for some time and you watch the gauge. If there is a drop, now you know, yes, the system is not tight. How you achieve static pressure test is a separate subject altogether. We can discuss that at length some other time. Static pressure testing is the requirement. Once, twice annually. In dry dock, it should be tested to 1.5 times. Okay, it's not necessary that you only do it in a dry dock. You can always do it anytime you want. Okay. The working pressure should not be mixed up with the design pressure mentioned in the piping diagram booklet. Piping diagram booklet tells you what is the design pressure of that particular pipeline, of that particular diameter. Okay. Working pressure is the normal pressure you work with. Design pressure is what it is tested to. Okay. When you do pressure testing, you go into that design pressure mentioned in the piping diagram booklet. Initially, the working pressure may be established by checking last 10 or 15 bunker plants, wherein the rate and the pressure at which the bunker is taken is mentioned. The average higher pressure from this plant should be taken. This will be the established working pressure, okay, which should be stenciled on the bunker line on deck near the manifold valve. Annual testing on board should be done to this pressure. Pressure testing of the line should be done by the fuel oil transfer pump. In some cases, the pump relief valve may have to be adjusted to a higher value to be able to achieve the testing pressure on deck. Okay. Obviously, if you're testing the bunker pipeline, it has to be with the bunker transfer pump, isn't it? So you can't be using anything else. In case the transfer pump is not capable of delivering up to the test pressure, bunker line should be filled up by the FO transfer pump. Okay, these are going into nitty-gritties. The idea is we need to test it, yeah, whether it is a bunker transfer pump or FO transfer pump or whichever it is, you test it. Testing pressure and date should be stenciled on the bunker line. For vessels older than 20 years, bunker lines are to be pressure tested every 6 months. As against twice in 5 years, it is now once in 6 months. Okay. Obviously, it stands to reason that the vessel is 20 years old. There are several sections of the bunker pipeline which probably never got renewed in this period of 20 years. It's quite possible. So you're just verifying that during the bunker process, the system is intact by doing this every 6 months. Precautions. Utmost care and vigilance must be exercised while carrying out the bunkering or transfer operations. The guidelines must be strictly adhered to during operations to avoid any spillage. Okay. Yeah, this is what we discussed earlier. Prepare the oil receiving plan in advance, taking into account the trim and list accurately accounted for in the calculation of quantities in various tanks. Bunkering checklist, the bunkering safety checklist in ship type specific manual is to be complied with. Each ship will have its own design, its own equipment, isn't it? So a ship specific plan needs to be made for that particular ship you are in. Right? Unless it's a brand new ship, it should be existing. When you go and join a ship, it's probably already existing because people before you, they've done it. If you're going on a brand new ship, then you create it, a ship specific plan. Safety checklist is to be signed by the chief engineer at the bunker, yeah, or the terminal in charge. Safety checklist is used for loading bunkers from barge when taking bunkers from jetty or when loading bulk lubricating oil or gas oil from the road tanker. In some countries, you get bunkers by road tankers, you know, the typical lorries what we have. You know. In some countries, in Indonesia and places, you will be surprised that they all come and they come in a very, very small boats and 1, 2, 3, 4 series of trucks they come and they pump in. But in that case also you need to follow the same safety checklist. The condition of the hose is one paramount thing. If you think that the condition of the hose is not appropriate, you have the right to tell him, no, I will not load bunkers unless this hose is changed. You see, visually bent and cracked and strands of its strengthening wires or whatever, anything is broken or chafed. you have the right to say, please, I will not use this hose, give me another hose. Okay. Okay, liner for bunkering to be set and double checked. As I said, one person does, one person verifies. Final soundings. Agree and bunker team will advise DB tanks not to exceed 90%. Okay, all this is as per your SMS. Okay, this is just a guideline as present here. Valves in the system not in use to be kept shut. We have discussed all this. Overflow tanks are empty prior beginning. Maintain record of the filling rate. Yeah, just like in cargo operations, while loading and discharging, you maintain hourly rates, isn't it? What happened in the last hour, what happened in the last 6 hours, what's the estimated time of completion? These are the things which you note down, which you keep a record of also. Huh? Your company also wants you to record it. So if your bunkering is going to be a lengthy process of 8 to 10 hours, then you do better to track it. Every hour you check what's happening. So you are monitoring at each stage. Maintain record, ensure soundings in tanks not being filled up, remaining the same. Those tanks which you are not taking bunkers in, they must actually have the same reading as before, isn't it? So monitor them also once in a while. Not once in a while, regularly actually. Check sample for correct viscosity, density and flash point. Any abnormal values to be reported, protested to safeguard interest. Exercise caution when changing over tanks. Open fully valve. Okay, these are the process, the procedure. You can write it down if you want. Check the line pressure constantly, yes. You check the line pressure constantly. Inadvertently somebody closes a particular valve, the line pressure shoots up. Isn't it? So you don't want pressures to go beyond its rated pressure. Reduce rate to safe up mount, adjust mooring lines. Okay, these are the normal standard things. What we do, maintain watch on both oil spill. End of transfer, exercise caution when blowing through lines, especially if the tanks are full. Secure valves, fit necessary planks, flanges, check final sounding, clean up containment. Hello. Break. Okay, one minute. Let me finish this. There's just a little bit left. End of transfer. You know all this. In case of accident, okay. In case of accident spillage, now please remember, this is very, very important. You first inform the authorities. Obviously, you first stop transfer procedures and all that. Inform the authorities concerned. Inform the port control, inform the agents. You must notify people. This is very, very important in today's time. If there is a spillage, stop and inform. You are found guilty if you do not inform the authorities that such an incident has taken place. Okay? While bunkering or while cargo loading or discharging, any incident on board your ship, please inform. Information is very, very important today. Then do, of course, minimize spills and assist in cleaning operations and things like that. Information, you must transmit that information post haste to whichever port you are in and whoever else is. Okay, we'll finish the pollution part of it. Quality and quantity control. As I told you earlier, after bunkering is over, you take the sample and you send it to a testing authority. Yeah, several of them. Biswa Lab is one which is very, very famous because it's run by an Indian and he's got branches all over, and also very, very good facility. And he gives you the quality certificate of the bunkers, and it tells you what is what, and then the company advises you whether to use it or not. He typically tells you green signal is yes, you can go ahead and use it. Sometimes if there is a variance, then you ask the company for further advice. Look at this 1.5.5 with the impact of environmental legislation and awareness. The nature of MDO or HFO contamination is changing. Recently, a vessel bunkering from a barge received HFO with a flash point dangerously below the 60 degrees centigrade minimum required by Class N, SOLAS Chapter 2.2. Okay? Flash point of all those oils, HFO and all that, they need to be above 60 degrees centigrade. Right. So, if there is any doubt on this account, it would be prudent to ensure proper custody transfer sampling is done. This is the reason we take sampling at the start of the entire operation. and witnessed by a third party who is not a ship's officer. Sampling is done, sent for analysis, and bunker not used until analysis report is received. Okay, this is a prudent thing to do, and which is what most companies are following the pattern. Where available tank space makes it possible, bunkers are not to be mixed. Where available tank space makes it. Now, nowadays we also have the CICA regulations, and sulfur content below so and so has to be stored separately and used only in special areas, kind of a thing. So lots of ships either have existing tanks and they renominate it. Okay, this is meant for regular fuel and this is meant for the CICA area fuel, whatever, the low sulfur one. Some ships don't have it and they are in the process of modifying it, or maybe it's already done and that's why I have no idea. So in which case, it's prudent to make sure that what you're receiving, that tank is empty. Okay. Where available tank space makes it possible, bunkers are not to be mixed, the old and the new. When bunkers are mixed, a sample with the ratio as in the tank is to be sent for analysis also. If it is unavoidable, you have no other space, then that tank, the old bunker, you need the volume and the temperature and its original density as supplied by the bunker supplier, then along with the new quantity which has come in, you take this composite sample and send that also for analysis. Right? In either which way, you are looking at an analysis to tell you whether you can go ahead to use it or not. Bunker samples during bunkering is to be taken with a drip sampler only. Yes, it's a particular sampler. You just can't open the cork and fill up a bottle. So it is done by a drip sampler which samples throughout the process of bunkering. It takes drip by drip as you are bunkering. It's not just the first burst or something, It's continuous sampling throughout the period of bunkering. Okay, understood? Because it is drip by drip, drop by drop, he is collecting it over a period of the entire bunkering period. So what you actually now have is a cross section of the total bunkers which is coming. The bunker barge might have different tanks. He is pumped a little from here, a little from there, a little from there, isn't it? So what you get is a continuous sampling throughout the process of bunkering. This is the requirement as per IAPP, and vessels are to comply with procedures and requirements of MAPOL Annex 6. Vessels are to be aware of emission control areas where only low sulfur fuel and diesel is to be used. Do you understand what is low sulfur, low sulfur, regular? What is meant by regular sulfur, low sulfur and low sulfur? You must be aware of this. Regular bunkers generally have what? More than 5%. More than 5% of sulfur. Low sulfur is less than 5 up to 2.5, isn't it? And sulfur quantity less than 2.5% qualified as low sulfur. Okay. In India, you have Agra, where you have this Taj Mahal, right? Like Agra, there are other places also where the monuments the government of India wants to protect, and they've got a protocol, they've got a rule there. In Agra and Mathura areas, in a particular radius which covers so many kilometers from Taj Mahal, only low sulfur diesel has to be used. This is mandatory. You cannot put regular diesel in your cars or bikes, which not bikes, in cars or trucks which use high-speed diesel as a fuel. Okay, so that's the reason. Special areas, they don't want too much sulfur in the atmosphere, so their requirement is low sulfur. Ship-specific procedures as per IAPP for changing over to low sulfur fuel and diesel is to be complied with as per ship's specific procedure which has been prepared after discussions between the vessel superintendent and the vessel. When the equipment in use is using a particular fuel, it takes time from there to the piping to come and to be utilized by the equipment, either the generator or the main engine, isn't it? So you calculate how much time this takes and start injecting the low sulfur fuel at an appropriate time as you enter the zone. You don't want to start it too early because low sulfur fuel is expensive. So you want to time it just about right, give or take 5-10 minutes or 15 minutes. But that is what chief engineers generally do. They ask you for notice, what time are we entering the Sika zone? And the officer in charge will give him an ETA, so much time. He'll reconfirm. Right? He wants that much time for the old fuel to go into the system and be utilized. And the low sulfur fuel is actually in the equipment at the time you are entering the special zone. Okay? So certain calculation is involved which the chief engineer does, but your job is to tell him how much time, at what time you are reaching a particular area. Okay? Vessels to be guided by the following for maximum percentage capacity, that is to be filled for bunkers. For DB tanks, so much percent, 85%, full bunkers are to be taken, 90% is acceptable. However, slower pumping rate and due caution. For shoulder deep tank, the recommended fill percentage is 95. This can be increased to 98% on a case-by-case basis in consultation. Wow. This is a guideline, okay? Your company specific SMS will tell you up to what percent you fill your tanks up, okay? So be guided by that. Follow your SMS, read your SMSs carefully. During the voyage, bunker tank sounding must be physically checked by a responsible engineer. Okay, all this is a routine thing. During bunkering, every day you need to know your consumption, so you will be sounding, okay? You will be calculating the volumes, giving it to the chief engineer for you to calculate all the consumptions, and everything is gone to various parties by the known report, so you need to be more or less as accurate as is possible. Fuel ROV figures to be calculated by the chief engineer using sounding note. Okay. Bunker analysis report. Upon this, of course, we discussed earlier. Once you send the bunker for analysis, you get the analysis report based on which you will take a decision whether or not to use that bunker for your design equipment. That completes bunker transfer procedures. Okay, this is a sample of the bunkering safety checklist. You can find this checklist anywhere. You just Google it. You can download varieties of bunker checklist from wherever. A copy of this is also available where? In your ISGOT. Is it? I think ISGOT should have. Your company will have a standard checklist. Your company specific checklist is always there in your SMS. Okay, you be guided by that. But for the time being, if you don't have a format, you can either write this down. Bunkers to be transferred. First, how many tons? What's the volume at the load temperature? What is the loading temperature? What's the maximum transfer rate? And what is the maximum line pressure? These are all the given. First, you agree on this and discuss this with the barge master or the supplier, whoever is supplying the terminal or the bunker barge. And then you put down bunkers to be loaded in what all tanks. What are the tanks nominated and what are the grades nominated for those tanks? How many of the tanks you have nominated for HFO and how much for diesel oil or lube oil? What is the volume of that tank? Volume of oil in the tank before loading. So if there is any pre-content, what is that? Available volume is how much and how much are you going to load, and total what you have loaded. Okay, so these are all pre-calculated before you bunker. Then checks by barge prior berthing. The barge has obtained the necessary permission to go alongside the receiving ship. So this is a terminal protocol. He needs to have clearance from the port concerned that he can go alongside. He brings the fenders. Normally we don't put the fenders unless of course you are a specific trade chemical tanker, highly, you are traveling more to smaller ports and you are going alongside bigger vessels, so you will have your own fenders, but more often than not, the barge brings the fenders and you make sure that the fenders are in place before they come alongside. Adequate electric insulating means are in place in the barge to ship connection. That is the ship shore safety connection. Here, barge ship safety connection. That is to put both the vessels on the same potential. Okay? We have discussed static electricity before, isn't it? No, not with you guys. With the previous batch. Okay, so this is to avoid a fire in case there is static. Bunker hoses are in good condition and are appropriate for the service intended. You must always, as I said, check the bunker hose, and if you have any reservations, you can express that to the supplier and insist on him changing the hose. Checks prior to transfer. The barge is securely moored, there is safe access within the ship and the barge, effective communications. Write down the channel. Which one is the channel? Okay. There's an effective watch on board. Fire hoses and firefighting equipment is ready. Scuppers are plugged. Bunker tank vents are actually clean and they are breathable. Sometimes what happens is you have the vent pipe. It has got what? Right? Give me feedback, man. So it has got a wire mesh, and then it has got a topa on top, right? So it breathes in and out. As something comes in, it breathes, correct? You have to make sure that that mesh is clean. It's not clogged. Bunker tank, all the more reason you have possible clogging of that vent. Okay? You must inspect that at regular intervals and change that mesh as per company's instruction. Okay. Well, since we are talking about tankers, this is a tanker lecture, right? SOLAS has got a recommendation. Wire meshes on tankers or wherever wire mesh is being used as a breather. Therefore, ballast tanks, you do have wire meshes, right? On the, yeah, and on the pressure vacuum valves, on the PV valves, or the vacuum end, again you have wire meshes, right? What is the specification of that wire mesh? Anyone? Has anybody gone through the SOLAS to see what is the specification? What kind of a wire mesh is that? Can I take any? Huh? What? Any idea? You've been on ships, yes? Whether it's a bulk carrier or a container or a cargo ship.
Only the liquid part only.
We are not talking about liquid and solid here. I am talking about a wire mesh. This is a wire mesh. What is the specification of this wire mesh? Huh? You have to be a little louder. I'm deaf. Holes are small, big, large, extra large. That is not the term used here. Hey, naughty boy, put your mobile up there. Otherwise, I'll japti karo it now. Huh? What have you read the SOLAS? Anyone?
No, sir.
It's there in your construction and well, okay. To cut a long story short, I'll tell you this. You use one wire mesh, which is 30 by 30. That means 30 inches by 30 inches per square inch. That means 900 holes per square inch. That should be the specification of the mesh. In 1 square inch, it must have 30 this way and 30 this way, 30 rows and 30 columns. Okay? 30 by 30. This is one recommendation by SOLAS. What if you don't have a 30 by 30? Then what do you do? Then you are allowed to put two 20 by 20 and make a mat. That means you'll have 2 layers of 20 by 20. Understood? This is a requirement by SOLAS. SOLAS does not give you a choice. It's always shall and should. Okay? But in this 30 by 30 or 20 by 20, he is giving you a choice simply because it might not be available at a particular port when you are trying to source it out. Isn't it? If you don't have 30 by 30, it doesn't matter. You use two 20 by 20. He is giving you a choice, either this or that. If you put two 30 by 30, the tank will collapse. If you put two 30 by 30, the tank will collapse. It will not breathe at all. Okay? Very important to prevent implosion of tanks. or explosion of tanks. When liquid is taken out, you always need to supplement it by another media. In cargo tanks, we put inert gas. But in bunker tanks, we don't. We don't put IG there. And when we are putting bunkers into the tank, it's breathing through these meshes. It's very, very important that these meshes are kept clean and inspected at regular intervals. Okay? They heat the bunker tanks, you know that, right? They heat the bunker tanks. Therefore, whatever comes out has also got residues of oil. And that oil being viscous, it will coat. It will coat that wire mesh and make it, render it unusable. So it's very, very important. Bunker tanks especially, you check the vents at very regular intervals. Okay, so all scuppers are plugged, bunker tank vents. Initial lineup has been checked and unused bunker connections are blanked and fully bolted on the other side. Transfer hose is properly rigged and fully bolted and secured to manifolds. Overboard valves. Overboard valves connected to the cargo system, engine room, bilges, bunkers. At all times when you are alongside a terminal, you make sure your overboard valves are closed, except for ballast overboard in case you are engaged in ballast, deballasting. Okay? All cargo and bunker tank hatch lids are closed, and the tank securing cleats are also tight. It's not enough if you just swing it and say that okay, this is closed. No, you need to batten it down and secure the cleats. Okay? Bunker tank contents is monitored at regular intervals. There is a supply of oil spill cleanup material ready for immediate use. The main radio transmitter aerials are earthed and the radars are switched off. Why do you do this? Again, this is pertaining to tankers, and this lecture also is tankers, although we are discussing bunkering. Why do you do this? The main radio transmitter aerials are earthed and radars are switched off. Why? What? Give me a reason with that. What radiation? So out at sea, your chief officer does not do any tank cleaning, saying that the radars are running, therefore I will not tank clean. Huh? What happens to the radiation then?
Oil is going through the pipes.
So during tank cleaning also you have an explosive atmosphere somewhere. Huh?
The fumes which are coming from the bunker barge.
Fumes coming from the bunker barge. Why is the bunker barge giving out fumes? He is the one who is giving you cargo.
When the flow is through the...
When the bunker barge is pumping to you, he is not producing fumes. He is taking in your gas or something.
Fumes from the funnel of the bunker barge.
No.
Because of the engine running gas.
Out at sea, I am doing tank cleaning, I am doing gas spraying. I tell the second officer, hey Charlie, put the radar off, man. Radiation हो जाएगा, क्या हो जाएगा? Explosion हो जाएगा, yeah? Does that actually happen on your ships, on tankers? Yeah? Did you put the radars off and isolate your main transmitters? Did you do that? Why then you're doing this here?
Every time transmission of flow
of liquid is there.
So it causes
what?
It causes the static electrons to be...
Flow of liquid is going inside the hose, is going through the manifold and going, right? And the hose is also nice and thick. How can a main aerial or a transmitter, that radiation, you mean it will penetrate the hose and go and hit the oil?
If some leakage or something.
Well, we can keep going on and speculate all kinds of funny things, but the truth is this. On your ship, with respect to you and your ship alone, the radars and the antenna, they are fitted abaft the safety bulkhead. So it's a safe zone there. Considering the fact that the radar antenna is mounted at a particular height, the chances of a hazardous atmosphere happening anywhere is ruled out. Yeah, you have relative wind on deck and it takes everything away. So what you have up there is a rarefied atmosphere, too lean atmosphere for fire, isn't it? On your ship you can keep running the radars even during tank washing. It does not affect your operation. But now in a port, when you are in a terminal, your radars are in the safety barrier, above the safety barrier, but when it encompasses the whole port, you are not safe. Your radiation emitted from your equipment can go and cause damage elsewhere, not necessarily on your ship. That's the reason you put the radars off and put your transmitters, main transmitters, you earth them. Understood? With respect to the port facility, your radars are not located in a safe area. But with respect to your own ship out at sea, everything is safe. That's the reason you make sure that the radars are, the antenna is not rotating. Okay? In Shell company, they don't put the radars off at all. They only put it on standby. On all Shell vessels, they come alongside, they put it on standby. They don't believe in putting it off. For what reason, I have no idea. But elsewhere, on all the ships, all the other companies I have seen, we tend to put the radars off. And we also put, please do not switch on the radar, additional warning. Okay, that's the reason you need to do this. Please do this diligently. Yeah? With respect to a port facility, your ship is not in a safe zone. Huh? Understand? That's the reason. Fixed VHF, UHF, transit, ASF, correct power or switched off. Smoking rooms have been identified and smoking restrictions are being observed. Naked light regulations. Okay, these things are pretty much given. It is very identical to the ship shore safety checklist when you are engaged in cargo operations also. External doors and ports are closed, material safety data sheets have been exchanged and posted in the appropriate places like crew mess rooms, engine control room, officer mess room, somewhere. Yeah, anyways, yeah, very well. The hazards associated with the toxic substance in the bunkers being handled have been identified and understood.
Yeah.
Okay? So the hazardous thing what is associated with bunkers typically is hydrogen sulfide and benzene. Generally these two compounds. Yeah. So since this is a checklist, it's also kind of an agreement executed between two parties, right? So everybody says yes, and puts down everything. They make this declaration. For the ship, one man signs. For the barge, one man signs. Pay attention to this coded word R. Wherever you see R, it means it merits a repeat check at regular intervals. In case you have not noticed in the previous pages, all external doors and ports in the accommodation are closed. This calls for a repetitive check. Isn't it? People are coming and going and some person has left a door open. So check. This has to be repeatedly checked. Material safety data sheet for bunker transfer has been exchanged. I don't agree with the R here. It's not a repeated thing. But H2S content, benzene content, as I said, during bunkering also you check what's the content of H2S and benzene. Smoking rooms, repeatedly check whether the doors of the smoking rooms are closed. Yes, that calls for a repeat check. And in some companies they give you another sheet where you sign it. And they say check every 1 hour or check every 2 hours or check every 4 hours. Somebody has to sign. The person who is gone to verify it and the person who is monitoring. Like the duty officer tells the AB, go and check everything, and he reports, okay, everything is okay. Duty officer signs, okay, fine. It's been, a repeat check has been performed. Okay? Finally, okay, after all the declaration, here, this is what I was talking about. Record of repetitive checks, yes. Date, time, initials for the ship and for the barge. Sometimes the loading master stays on board in case of cargo operations, you know. He stays on board and monitors the entire, throughout the duration of the cargo operations, and he also checks along with the officer or whoever else. So he also signed. In this case for the barge, and in case of a cargo operation, initials of the loading master or the terminal in charge who is present, or the safety officer. Sometimes there is only a safety officer on board. You give him a separate cabin and he comes and goes and comes and goes. His attitude is only to monitor the safety part of it. He's not, excuse me, he's not worried about the loading rates. He's worried only about safety. Whether your doors are closed, whether AC intake is on internal and not on external. He'll go and verify whether the moorings are okay, whether the emergency towing wire is at the correct level. So in case of fire, the trucks can come and take it. As the ship is rising and the emergency towing wire, the bite also is too high, then it is counterproductive. So the safety inspector sometimes keeps checking and advises the vessel. Okay? So that's about bunkering. You want to write something down? Should I present the previous pages again? Yes or no? Say that again?
Can you send the notes in school or
Send the notes to you. I don't know how to do it.
Send to IS. He'll send us.
I don't know how to do it.
No, so give it to IS. Notes just tell IS to send us.
Okay. Yeah, I'll tell Captain here. Yes. It is in fact his folder only.
Oh.
It is in his folder, and I'll tell him. And you guys have got a group, is it? Where Captain Ayer can send it to you?
Yes.
Oh, okay. All of you are there.
Yes.
The new batch, old batch, everyone.
Everyone.
That is